Here we got another example of method of sections. They want us to find the force in members ED, EH, and GH, which obviously makes me want to cut this thing right through here to expose those three members. So which side am I going to work? The left side or the right side after I section it? Well, if I look at the support reactions, there's two support reactions at A, one X, one Y. There's only one at F. So I'm going to find that support reaction at F, and I'm going to work the left-hand side. So that's step one. Find the support reaction at F. So what does the free body diagram look like? Let's see if I can draw this thing. Here's the left hand, or the top, and then this. That's kind of sort of what it looks like. So now what forces are applied? There's a reaction support there. There's also a reaction support here, and one here. I've got a load there. I've got a load there. I've got a load there. And this is a very sloppy picture. I should make that much neater, but it's the best I can do on this screen. So now I'm going to do the sum of the moments. I want to find that force at F. So I'm going to do the sum of the moments about A equals 0. And rather than worrying about which side's positive, which direction's positive, and which direction's negative, I'm going to make everything that makes it rotate clockwise on one side and everything that makes it rotate counterclockwise on the other side. So clockwise rotation is going to be Fy times 4 meters. That's the only one of those forces that makes it rotate clockwise about A. On the other side of the equation, all the counterclockwise rotations. So I get the 40 kilonewtons times 2 meters. The 50 kilonewtons doesn't produce a rotation about A. The line of action passes through A. Then I get 30 kilonewtons times, how far is that? It's 3 meters plus 40 kilonewtons times 1.5 meters. And I solve that for Fy. And what I find is Fy is 57.5 kilonewtons. So far, so good. So now, like we said, we're going to section it right there. We know that Fy is 57.5 kilonewtons. So now we draw the free body diagram after I've sectioned it. So I'm only looking at this piece. Now what forces are acting on this? I've got this force Fy. I've got a load here at E, that's 40 kilonewtons. And then I'm going to make all of these other forces point out. So this one's going to be FED. This one's going to be FEH and FGH. So I want to choose one of my conditions of equilibrium that only has one unknown in it. So I'm going to choose to calculate the sum of the moments about E equals 0. This is point E. And you notice that two of those unknown forces pass through that point. They don't produce a moment. Right, the 40 kilonewton load doesn't produce a moment. So the only things I've got producing moments are Fy and FGH. So Fy makes it rotate counterclockwise. So Fy is going to be times 2 meters. And that's got to be equal to FGH, which makes it rotate counterclockwise, and that's a distance of 1.5 meters. I solve for FGH, and I get FGH is equal to 76.7 kilonewtons. Because that's positive, it's in tension. That's one of my answers. And I'm going to make this a little smaller so I got room to work. So now what do we do? Now let's do the sum of the forces in the y direction. Right? That only one of these unknown forces, I've only got 2 unknowns left. Only one of those unknown forces is in the y direction. Right, I need to know this triangle. What does this triangle look like? The triangle's, that's going to be 4 this way, 3 this way, 5 this way. It's a 3, 4, 5 triangle. So I'm doing sum of the forces in the y direction. So I get Fy minus 40 kilonewtons minus 3/5 of FEH equals 0. Solve that for FEH. I get 29.2 kilonewtons, and this is also in tension. So the only thing I've got left is FED. So I'm going to choose to do the sum of the moments about H equals 0. Now H is over here off the picture. It's not part of the piece I cut, but 2 of those forces pass through that point, so they don't produce a moment about that point. So clockwise rotation, so I get Fy, which is 4 meters from H, plus FED times 1.5 meters. Those both make it rotate clockwise about H. And then counterclockwise about H is that 40 kilonewton load, which is 2 meters. So I solve for FED. I find FED is minus 100 kilonewtons. So FED is 100 kilonewtons compression. So there's my 4 answers, or 3 answers. And we're done.